Hi, welcome to our session on Java binary trees. In the previous session, we have started working on trees and binary search trees, and we have completed how to create the binary trees, insert and traverse in order in lesson number 9. In today's session, we are going to continue our discussion and we are going to see various tree traversal methods. So as you know, we can traverse the trees in order to identify the nodes in it. So there are several ways with which we can traverse the trees. Okay. So we are going to use the same tree and we are going to traverse the same tree with different mechanisms. So the most common search techniques are depth first search and the breadth first search. Okay. So in this session, we are going to implement the DFS, which is the depth first search. What is depth first search? DFS is a type of traversal where you go as deep as possible down one path before backing up and trying a different one. Okay. So what is the meaning of this? We are going to understand how the depth first search traversal works. There are several ways to perform the depth first search, and it is in order, pre-order, and post-order. Okay, so we have already seen the in order, the traversal in order. We have already implemented how to traverse the tree in the order. Now we are going to implement the pre-order and post-order. But before that, I want to show you how the depth first search works. Okay, so I'm taking you to the binary search tree, and I'll show you one example with which we'll go.NET. So here we have the binary trees. Okay, so this here we have an example of the binary search tree. So what you can see, a binary search tree is a binary tree in which each vertex has only up to 2 children. So this we have already discussed what is a binary tree and what is a complete tree. All those we have seen, but you can also read about all of these with BST and the balanced binary search tree and how the search operations are done, how the traversal is done, how the pre-order, in-order, post-order traversal is done. Okay. Now, so I'm going to show you the example. I think I have here the depth first and the breadth first. So I escape for now. And here I have the tree traversal mechanism. So what am I going to do? First, let's say I'm going to create my custom list. Okay. So I'm going to start with the one with which we have inserted in the same order in our code. Okay. Okay. So in our code, you can see we have inserted in this order. So we got a root node, which was 5. Okay. Then we have got 2, 4, 8, 6, 7, 3, 9. Okay, so we got the root node 5. We got 2 inserted on the left. Then we got 4 inserted. 8 was bigger. So we inserted 8. Then 6 was inserted. Then we got 7. And finally, we got 3 inserted. So this was the tree which we created here. Okay, and you have already seen the mechanism. If the insert point is found, we are going to create the new vertex. If value to be inserted is less than the key, we will go left, else we'll go right. So this you
But
already
you
do.
said that, each node should have like two like two nodes below it. So in
So
this
that's a
case,
balanced
one of
tree. So we can insert any more number of elements, you know. So now, so it totally depends the sequential order with which how we are making it. You can currently consider it as a binary search tree, which can have at most two nodes, not more than that.
okay.
Okay. So one is fine, but
Yes.
it cannot have more than two nodes. Okay.
So it said that it should have zero or two nodes only. It cannot have one node below it.
No, we can have one node. That is not a problem. We can have one node in the tree, in the binary search tree. Okay. So it's a completely balanced binary search tree where we do have to maintain the nodes in such a way that, you have the elements appropriately. If I have put the elements appropriately in sequence, then I might have got the properly balanced tree, you know. So let's say if I have inserted 5, then I've inserted 2, then I've inserted 3, then I've inserted 4. So in that sequence, I would have got an appropriately balanced tree. Okay. Then I would have inserted 6, 8, then 6, then 9 accordingly. So it would have been maintained properly. Okay.
Okay.
Now, so what do we have is now we have to work out on the traversal techniques. So we traverse the in order one. So when we start the in order one, you're going to go to the root node. Then you're going to check the left node. Okay. You'll traverse the left side of the tree first, then you'll go to the right hand side of the tree. Okay, like that. So we are going to get the tree traversal in this manner: 5, 2, 4, 3, followed by 8, 6, 7, and 9. Okay. Now, similarly, when we traversed in this in order traversal, now what we have to do, we have to implement the pre-order and the post-order traversal also. Okay. So these are the types of depth first search techniques with which we can observe the depth of the tree. Okay. Now what are we going to do? We are going to implement the pre-order traversal. How the pre-order works? Achha, currently they don't have the pre-order and the post-order. Chalo, anyways. So the traversal thing you already understood. So now we will see what is the in order traversal or the pre-order traversal. Okay. So in the pre-order traversal, what happens? In pre-order traversal, you visit the root node first, then the left subtree, and finally the right subtree. Okay. That is
Okay.
something pre-order traversal. So So that's how we are going to implement it. So how is it going to happen? You're going to identify the node. Okay, I'm going to give the nodes. Suppose I've given the node 5. Then I'll see if it's not null. So what I'll do, I'll get its value. Then I'm going to traverse the pre-order functionality and I'm going to traverse the left node. And similarly, all the left nodes of that node will be traversed. Once all the left nodes have been traversed, then we will perform traverse pre-order for the right side of the node. Okay. So that's a very simple order of how to, identify and print the values of the node. So it's going to be a recursive function. Okay. And we are going to get the elements recalled. So what am I going to do? I'm going to write the new functionality. So I'm going to define this method. Let's say we call public void traverse pre-order. I'm going to define the node. Let me just adjust it a little properly. Yeah. So we are going to define the travels pre-order. So we just need to check in case If the node is empty, then nothing is going to happen. If node is not equal to null, we are going to do nothing. Otherwise, what we are going to do, we are going to print the values of the node. Okay, so we are going to get the value of, let's say we are going to keep a space, and then we are going to get the value of the node. Okay, then what are we going to do? Once we got the node value, we are going to traverse pre-order with the left side of the node. Okay, the left child of the node. So we are going to get the left tree traversed first, and then we are going to traverse the pre-order for the right side.
Okay.
So what is the pre-order traversal does? In the pre-order traversal, we traverse the left tree first and the right tree first. Okay. Otherwise, what we did in the normal order, we get to see the left element, we print the value, we get to see the right element, like that. Okay. Now, so now what do we have to do is, let us just quickly test it. I'm going to save it, to test the code. So I'm going to write here pre.traverse pre-order. Okay, this is the functionality, and I'm going to traverse the root node. So let us run it. So once we run now, I will just quickly print here system.out.println traverse pre-order. Okay.
Yes.
So what have we got? We have inserted the tree 52588648. So we got the root node printed 5. Then we have got the left tree 2, 3, 4, 5.
So why 2 is printed again?
Sorry.
So why 2 is printed twice?
Why it printed? What are you saying? No, I do need to check why it printed in this order. The order should be, we have got the 5, then we have inserted 2. So we should have got 2. Okay. And then it didn't have the left tree. So we got nothing. We got 2 itself. Okay. Then it should have printed the right tree. Okay. Let me just quickly check back. Then the left subtree, and finally the right subtree. Okay. So root node we have printed well. The left we have printed, but we haven't got. So we should have got the output in this way, 5, 4, 5, 2, then the following elements, like the way we got in the previous traversal, where we got 2, 3, 4, 5, 6, 7, 8, 9. Similarly, we should have got this one also, 5, 2, 3, 4, 8, 6, 7, 9. So now am I going to check? I have given the node in. The proper node has been given. I've checked the node, printed the node value properly with the println functionality. Oh. Sorry, I printed node.left mistakenly. Should be node.right, the right subtree. Okay. So that was the mistake I did. And that was a typing mistake, So initially, what are we going to do? We're going to traverse the left tree and then the right tree. Okay. traverse the root node, traverse the left node, and then traverse the right node. I'm going to run it. Now you can see we are going to get the proper tree printed. Okay, 524, then 386, and 79. Is that clear?
Yes.
Now, similarly, what do we have is we can do traverse the post order also. So in the post order, what happens? In the post order, you visit left subtree first, then the right subtree, and the root node at the end. Okay. So first you will be traversing the left tree, the right tree, and then finally the root node. So that is traverse post order. So I'm going to write public void traverse post order. So I'm going to define the post order. I'm going to define the node n. So I'm going to give the node value. Again, I will check if the node is not empty, because if the node will be empty, we are not going to print anything. Okay. Else, what are we going to do? We are going to traverse post order, and I'm going to get node dot left. First, we are going to traverse the left subtree. Then we are going to traverse post order the right subtree, and then finally I'm going to print out the value of the node. System.out.println, and I'm going to print the value of node dot value. Okay, is that clear? So that is the traverse post order. So in the in order, what we do traverse the left first, then the node, and then the right tree. In pre-order, we get the node, then the left subtree, and the right subtree. In the post order, we do the left subtree first, then the right subtree, and then finally the node value. Is that clear? So I'm going to save it and run it, and I'm going to call the functionality here. So I'm going to print system.out.println, and I'm going to define traverse post order. Traverse post order, and I'm going to print tree dot traverse post order, and I'm going to traverse from the root node. Okay, so I'm going to start the search, and now I get the traverse post order also. So in the traverse post order, I will reach out to my leftmost node first, okay, which is 3, then 4, then 2 sequence. Then I'll go to the right subtree. I'll go up to the end, which will be the 7. Then I'll get the 6. Then I'll get the 9, okay, in sequence because it's on the right. Then I get the root node, which is 8. And finally, I get the main node, which is 5. Clear?
Yes.
Yeah. So here we get the final output as 3, 4, 2, 7, 6, 9, 8, 5. Okay. I believe this is clear to you how this node mechanism works. These techniques are the depth first search technique. So you go to the depth node first, okay, and you get them printed. Similarly, there is another technique which is breadth first search. So this type of traversal visit all the nodes of a level before going to the next level, which means you're going to print the elements of the current breadth first, and then you will get into the next level, which means currently what are we doing? We were searching in this mechanism. Okay, we were searching in this mechanism, depth first search. Okay, so we were getting the depth element first, and then we are printing in the reverse order. But now what are we going to do? We are going to do breadth first search. We are going to read this breadth level first, then we'll get to the second list element. Okay, then we'll go to the third list element, like that. Is that clear? So this is the breadth first search. And on the left hand side, this one is DFS, the depth first search. We print the depth element first. Okay. And this is the BFS, which is the breadth first search. Okay.
So the breadth first.
Yeah. Your voice is not clear. Hello, am I audible? Hello.
Yes. So I was asking in breadth first search, it will start from the top or the bottom?
You
Like
were
it
asked,
is based on the level. So it will start from the top level or the bottom level.
yeah. So from the root node, so now we can define in the way with which how we want to get the data printed, you know. So in the way we decide the in order, the post order, and the pre-order. Similarly, in the breadth first search also, we are going to see the possibilities. So earlier in the depth first search, what we did, we get printed in this order, which was the in order. We first traversed the root node, and similarly, then we got on the left hand side of the node and then the right hand side of the node. Okay. So since the the search was the depth first search, but we can print it in any order. We could have printed the root first or the root last. Okay. So it depends on the search mechanism. How do we want to traverse all the elements within that tree? Okay. Is that clear? So I'll show you how we do that. I believe this is clear. Hello. Am I audible? Hello. Hello. Is my voice audible?